Okay, today we're going to be testing a LiGO battery. These batteries are made by Grin Technologies. They say they have 98 watt hours in one battery, which actually makes them legal to fly with. And today I'm going to see, can you really get 98 watt hours out of one of these batteries? Well, welcome back to the channel. As I alluded to in the intro, when we did our conversion of our ice adventure trike to an electric hub versus the Shimano step system that you can get with it, I went with a company called Grin Technologies out of British Columbia. And one of the batteries they sell is a 98 watt hour battery that is apparently airline compatible. So the idea was, if we could get these batteries, we could fly our TerraTrikes and continue our adventures. But I've never actually tested one of these batteries to the point, do you truly get 98 watt hours out of it? And so today's ride, nothing too exciting, not like last week where we were down in Denali National Park and getting turned around by grizzly bears. But today really is going to be an out and back. And the goal is to connect one battery, which I've done, and it's to ride it until it quits. And it says, I'm done, no more, and to see how many watt hours of capacity I get out of that battery. Because if I can determine that, then I have a great deal of accuracy in terms of how far I can go based on one battery or two batteries or four batteries or however many batteries I want to connect. And then like the Shimano step system, where you get a battery indicator that says you've got 5 bars or 2 bars, and then there's another screen that estimates how many miles you've got left. You don't really actually know your battery consumption per mile based on that day's ride, whether there's hills or wind or coasting or any of those factors. So that's today's ride. Will I really get 98 watt hours out of a 98 watt hour battery? So we're just getting ready with our ride, and a couple things that I guess the parameters of how this works is this test really is independent of how fast we're going. I mean, right now we're traveling at, I don't know, 12, 13 miles an hour. It's really independent of my cadence, which averages about 70 RPM. It's really independent about how much assist that I do or don't want based on those other factors. And so right now I've got my cyclometer, and because it's programmable, I've got 24 levels of assist. So right now I'm at assist level 3 because I've also got the pedal pushing wife kind of pushing the wind for me, so I could draft right behind her. But the real test is, regardless of speed and cadence and whether there's hills or downhills, it really has to do with battery consumption. And so sure, if I can put my battery consumption way down, I'll be able to go way more miles. But what I'm really looking at is, I want to know if the battery truly holds 98 watt hours of power. And so I think I can show this if I don't run into the pedal pushing wife. But that is the cyclometer. And what I'm seeing right now is I'm currently at a burn rate, if you want to call it that, of 4.5 watts per mile. And I have consumed 7.6 watts of power from that battery. Well, if that's all accurate, which I'm assuming it is, that would tell me that even if that was up at 5 watts per mile, this 98 watt hour battery, I should be able to get almost 20 miles off this single battery. So if I were to stack 4 of them together, which I really ride, that means suddenly I've got 80 miles. But again, that's just because right now that watt burn, it's at 4.5. I imagine here in a few miles when we start climbing a few hills, we're going to see that number change a little bit. So at this point we're up to burning 15 watt hours off. Our watts per mile is at 4.9, so still relatively low. So it looks like we've burned off about 30 watts so far. Had a little malfunction climbing up the hill. I turned the system off and manually climbed. I was wondering why I was feeling even older than I do at times. So I don't know, just shy of 10 miles into the ride today. And based on the cyclometer, when I look at the screen that indicates watts per mile and how many total watts we've burned, I'm still at 50% of battery life. But when I look at the different screen that shows a little battery indicator, the little icon, it certainly looks like the battery is at lower capacity than that at the moment. So this is part of the experiment because I like precision. It's just kind of part of what I do. And so I don't want to get a guesstimate based on the icon. I really want to have the exactness of how many watts of this battery have I burned. So right now it looks like about 50%, which if that holds true at our current pace and everything we're doing, it should give me about 20 miles on this battery. So we're getting close. We're getting close to seeing how this experiment goes. So we have now covered roughly 15 miles, but again, it's not about the miles. It's about how accurate is that battery consumption. So on the cycle analyzer, right now, I have no bars showing on the first screen where you see the battery indicator icon. There is nothing there. It's saying the battery is done. But when I go to the next screen, and the next screen, and the next screen, now I'm seeing a little different story. Because according to this screen, I'm at 83 watt hours burned. My burn rate, as you can see, says 5.4, which tells me I've still got 15 watts of power, or roughly about 2 to 3 miles, which is about perfect because we're about 2 miles from the house. And just like that, the system just shut down. So I'm going to have to disconnect the dead battery, put the live battery back on to see where we are in terms of the burn. I want to say we are right at about 90 watts. So put that on pause for just a minute. I'll be back with you. All right, so we're back, and I hooked up the other battery I've got with me. And interestingly enough, the 98 watt hour battery at 90 watts, almost exactly on the money, is when it turned off. But then I also noticed that on the battery, one of the green indicator lights kind of indicating how much power is in a battery, it was still lit. So I think what I'm going to have to do is a little research, go to Grin's website and see if that is just a protection they build into the battery so that that final 10% remains, just so that it doesn't completely drain the battery, which I think with a lithium-based battery is not a good thing to do that complete drain. So we're hooked up. We're still out about a mile from the house. So good experiment. 90 seems to be the cutoff. I think the only way we can prove it for real is to, well, do this again some other time. But for right now, nice experiment. I think watching the the watt hours is the way to do it if you want real accuracy on one of these LiGO batteries from Grin Technologies. So thanks for coming along for our little experiment. As you can probably see, beautiful day here. We're sitting somewhere, I don't know, 60, 62 degrees. No wind for the first time in about 10 days. The traffic's starting to pick up. I guess other people have discovered it's a nice day to be out. But we're almost back to the house and we've had a very good ride. So, thanks for coming along. We'll see you on the next video.